So we are into the next segment here. We will be trying to draw some more polar graphs here. Okay. Look at this third question. We have to sketch this given polar equation, which is r is equal to 2 minus sine theta. Now, you should always see that if there are any values between 0 and 2 pi where this r can be negative, okay? So you should be very quick in sketching this. The axis of the curve is at 2. Yeah, this will not have any negative part here. And you see this is going to be your curve here. And this is 90, 180, 270, 360. Or in radians, this is 1. This is 3. Since there is a negative with the sine theta, so the curve would be going downwards like here, and then this, and then this, and then this. Okay. So this curve would be like this. So there are no worries. The curve will all have this will have all the values of r as positive. So we can uh, quickly, let me draw the table here. So this is theta, this is the radius, okay, the value of r. So I'll be taking this as 0, then pi by 2, then pi, then 3 pi by 2, and then we have 2 pi. Okay, but at theta 0, you have r equal to 2. At pi by 2, it is 1. At pi, it is 2. 3 pi by 2, this will be 3. And at 2 pi, you have, like, if you have this sketch in front of you, there's no need to calculate all these coordinates. At 0, we are 2. At 90, we are at 1. At 180, we are again at this 2. At 270, we are at 3. And at 360, we are at 2. Okay. So this is going to be 2 over here. So so just to make myself reinforce this, so these points are basically 2 comma 0, 1 comma pi by 2, 2 comma pi, and so on. So in general, we write these coordinates as r comma theta. Okay. So this is the case here. So let's have, this is the vertical axis. I should call them coordinate axes, okay? So we have to go up to 3. So this is 1, 2, this is 3, this is 1, 2, this is 3, this is 1, 2, 3. If we have a better, like, I have taken this length a bit longer here. Anyhow, so this is theta equal to 0 here. This is theta equal to pi by 2 here. This is theta equal to pi. This is theta equal to 3 pi by 2. Okay, now at 0 we have 2. So this is your 0, 2 comma 0 here. Okay, and when you have pi by 2, you are at 1. Okay, then at pi we are at 2. So we are here, and then 3 pi by 2, we are here at 3, okay, over here. And then at 2 pi, we are again at 2. So the sketch would be something like this. So the sketch is something like this, okay? If I had a better scale, you could have a better shape for this, okay?
सर
Yeah, yeah.
सर वन स्केच ये स्केच करते हुए जिस तरह हमें लास्ट वाले पार्ट के अंदर हमने एक एक वैल्यू दी थी जो हमारे उस पे नहीं थी एक्सिस के ऊपर इज इट नेसेसरी फॉर अस टू डू दैट
It is not at all required. Like sometimes if you're not clear that what kind of the curve is going to be, you don't have any connection between the 2 points, then you can, like, take even 30 degrees. Like you can check, for example, if I put uh, if I take theta as 30 degrees or pi by 3, you just want to check that at 30 degrees, this is half, okay? And r is going to be 1.5. So you see the 30 degrees is going to be somewhere over here, okay? So this does look like this radius is going to be 1.5 over here. You see that? Hmm?
यस सर
Yes?
Sir,
Okay. Yes, madam.
सर आपने कहा था कि वी डोंट टेक माइनस और प्लस ऑन दीज कोऑर्डिनेट एक्सेस, लेकिन जो आंसर वाली लिस्ट में बना है उसमें तो उन्होंने माइनस लिया हुआ है फॉर द वैल्यूज दैट आर अंडर
Because the thing is, we should know that the radius is never negative over here. Okay, he should have taken this as minus. We can only take the minus over here if we are considering this as our y-axis. If it is a y-axis, then yes, you can have minus values over here. If you're taking this as your x-axis, yeah, sometimes we are considering both the x. Again, a very good question, beta. You see, this discussion is very important. Like, suppose we are showing both the polar coordinates and the Cartesian coordinates over here, then yes, you can take this as -1, -2, minus, this is -1, -2. Then please don't confuse yourself that, you see, then you will be confused to see that, like, this is showing that at 3 pi by 2, we have the radius 3. Then this axis is showing as -3. Then why are we marking this at -3? So please remember that if this is purely showing the theta on these coordinate axes, okay, and then we are only concerned with the this distance from the origin. This is basically called the modulus, okay. So this r is basically the modulus over here. You will study about this in your complex numbers, okay. So this modulus is always positive. So this is going to be +3. Yes, we can keep both the Cartesian and the polar coordinates on the same diagram. Then you can take it as negative as well. And again, a very good question, okay? So you please keep this discussion on while we are doing these questions. Okay? Okay, the question that you have asked over here, that why this r is why we can't take this r as negative. The thing is, you must remember that this r that I'm mostly referring this as the radius here. This is basically not the radius. Radius is like, when you draw a circle and then you have the radius. This r is basically um, for different angles. You see that this angle is 0 and then this is pi by 2. So we are dealing with the polar coordinates, okay? So you're clear with this theta, then this r is basically, this tells us that what is the distance of that particular point whose polar coordinates theta is, let's say, 0, then what is its distance from the origin, okay? Normally, when we are dealing with the Cartesian, the Cartesian plane and the Cartesian coordinates, when we have a point 2 comma 3. Now this 2 comma 3 means that there is a point whose distance from the y-axis is 2 and whose distance from the x-axis is 3. So that is why we start from here, like we say, okay, this is going to be 2 and this is going to be 1, 2, 3, okay? So I am not taking this distance from the origin. I'm seeing that, okay, how far is this from the y-axis? And how far is this from the x-axis? So that is why this is going to be 2, 3. When we're dealing with the polar coordinates, we see that, okay, how much I should be rotating. Like if it says 90 degrees, so I say, okay, I am going to be somewhere like, onto this, like if I take this 90 degrees, so I am somewhere over here, okay? Then how far from the origin? So I'm told this is going to be 1. So this is the point over here. Now suppose as I took theta, let's say pi by 6, okay? So this is the locus pi by 6 over here, okay? So we are going to be somewhere on this line, but how far from the origin, okay? That is going to be your r. So you put your theta pi by 6 here, you get your r as 1.5. So that means this distance over here has to be 1.5. Suppose you take this theta as, let's say, um, 7 pi by 6, okay? When you take this theta as 7 pi by 6, that is basically 210. You're somewhere over here, okay? This is your 210. Now, this 7 pi by 6 is basically minus -0.5 or sine 210. You can check from your calculators. that sine 210 degrees is minus 0.5. So when you take this minus 2.5, I mean minus 0.5 here, so this is going to be 2 plus 0.5. So that means it's going to be somewhere 2.5 units away from the origin. Okay, so this R is
सर
basically,
अगर अगर
yes,
साइन
yes,
हमारा -0.5 है तो फिर वो 2 माइनस अच्छा अच्छा नहीं
minus minus plus
नहीं
हो
फिर
जाएगा
2
ना.
माइनस बोलिए
So this R is the
तो
modulus. Its correct pronunciation or correct name is modulus. Modulus means the distance from the origin. Okay, so you see this discussion is very important. So you talk more, you get more points. Okay, so let's go on to this sketch over here, which says we have to sketch R is equal to 1 minus 2 sine theta. You must be knowing that what is your first task. What will you do first of all if you want to um, sketch this? R is equal to 1 minus 2 sine theta. So you should remember, you will quickly draw its sketch. You want to know that for what values of theta this is going to be negative. Okay, this is 0, pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi, and your modulus is at 1. Sorry, modulus keh raha hu. The axis of the curve is 1, so the curve is going to move about it. This is going to be 2. The maximum point is 2 here, the minimum is -1. There is a minus with this sign, so the curve will go in opposite direction. 0 pe you have 1, then pi by 2 pe you will have 3, I mean -1 here. Okay, then pi pe you're again at the axis, 3 pi by 2 pe your maximum. So the curve is going to be like this. That is how you have this curve. Y is equal to 1 minus 2 sine theta. Okay, so this part over here, this, if you calculate this, like, when you put your 1 minus 2 sine theta equal to 0, you will see that this sine theta is going to be half. So theta is either pi by 6 or it is going to be 5 pi by 6. So here it is pi by 6 and here it is going to be 5 pi by 6. If I had written in a different color, then this could be clearer. Pi by 6 here, and this is going to be 5 pi by 6. Okay, now if we have to draw a sketch without this inner loop, just forget this inner loop for a moment. Okay, so we will be drawing these are the coordinate axes. Okay, and I have 0 here for those x and the y axis. Okay, we have to go up to 3 and up to -1. So this is 1, 1, 1. This one should be here. Okay, this is 1, this is 2, this is 2, this is 2, this is 2, this is 3, this is 3, and this one is 3. Okay, so it's 1, 2, 3, -1, -2, -3. This is -1, -2, -3, 1, 2, and 3. Okay, so bacho, 0 pe we are at 1. Okay, this is 0. And then you must know that what is happening at 30 degrees. So if I take 30 degrees here, 30 degrees is going to be tentatively like this. Okay, and then 150 degrees is going to be like this. Okay, so it is at 1 and then it is going to be 0 at 30 degrees. So this would be like this, drawn like this, and this would be drawn like this. Okay, and at 3 pi by 2, it is at 3 over here. Okay, so this is going to be like this and like this. Now, if you want to draw this inner loop over here, this inner loop is basically like when you consider the negative values as well. Okay, now what is happening at pi by 2? It is -1. At pi, this is your pi by 2. You see, this is your pi by 2. But look, you can take this value over here. Okay. So this would be a very interesting sketch like this. So this inner loop, you see right now here it is 3 pi by 2. Okay. But you're taking, if you consider the negative value, you see this is a chaos over here. You're taking a value of pi by 2 onto an angle which is 3 pi by 2. Okay. So this was basically at pi by 2, you have -1. So taking this as a vector quantity, if this was 1 over here, so instead of 1, we have to take its actual value, which is -1. So there would be a loop like this. Okay. So this is the sketch for now. Please ask some difficult questions over here and give me a tough time. Only then this will be clearer to you. Yes, please ask the questions here. Yes, your questions will make it clearer to you.
सर वो जो sorry जो हमारा y जो मतलब कि हॉरिजॉन्टल एक्सिस है उस पे जो हम कट कर रहे हैं तो उसकी क्या लेंथ होगी, मतलब उसका क्या मॉडुलस होएगी?
This length, this one, this is one.
No, the horizontal axis, the horizontal one.
Oh yes, very good question. Okay, you see that. For example, a very good question. But now let's take this as 60 degrees. Okay, so this is going to be your 60 degrees. If I put this as 60 degrees, again a very good question. Beta, this is going to be 1 minus 2 sine pi by 3. Please tell me its value quickly. What is this 1 minus 2 sine pi by? I think this will be 1 minus under root 3 because sine pi by 3. Yeah, what is this? Minus?
It's 0.96.
Minus 0.96.
Not minus. Not minus. So positive. It's positive.
It's not.
It will be negative, beta.
It-
1 minus
It's minus 2. It's minus 0.73.
minus 0.
अच्छा,
Yeah, 76, beta.
73. 73.
Okay, now just hold on. Now look at this, beta. Since we are forced to draw the inner loop over here, so I will be taking this over here. Look at this. If I extend this, so this angle is going to be over, like as this was a 90 degrees over here, and we took it on, mark this on to 3 pi by 2 wali line over here. Okay, so this angle is 60 degrees here. So this angle over here, let me change the color. Yeah, so if this angle is 60 degrees, and then if I extend this over here, so this is going to be another 60 degrees over here. So instead of taking this and on 60 degrees, that is impossible to draw because r cannot be negative, but we still have to draw this. So you see that this inner loop over here would be the value against it would be, you see, oh, I had to keep in green. So you see that this loop over here, what is this value? It is obviously less than this one. So this is 0.73. Okay, so we are taking negative values according to these angles. So the best way is you just go on like smoothly from here to here and just draw it like this.
If for a curve like this, we're allowed to put like minus in the coordinate axis.
We are, beta, we are like, I have already marked this as minus, but please see that your modulus is minus. So if you want to show that negative modulus, so you will have these inner loops over here when you will be drawing these negative moduli over here. You see, why do we ignore these negative moduli? Because, थोड़ा सा इसमें फिर ambiguity की तरफ हम लोग चले जाते हैं. So, but when you have to draw this inner loop, you will consider these negative values, and only then you can have these inner loops here. Okay. Now, let me give you a question here. You try to draw this r is equal to
Sir,
1
domain नहीं
minus.
निकालनी थी.
There's no need to do that. try drawing this. R is equal to 1 minus 2 cos theta. The question was that we had to sketch the inner loop and then we had to state its domain as well. So this inner loop is because of this part of the curve over here. Can you see that this is the part of the curve which is giving us the negative values of this y, which is our r over here, okay? So the y coordinates are negative because I have sketched here it as y is equal to 1 minus 2 sine x, okay, where x is the angle over here and y is this is acting as the r. So this y is negative from pi by 6 to 5 pi by 6. So this is what which gives us the inner loop. So inner loop's domain is, you can write that this theta is going to be between pi by 6 and 5 pi by 6, okay? We can ignore this equal mark because negative होने की वजह से ये बन रहा है हमारे पास, ठीक है? You can include or ignore them, ठीक है? So that is the domain for the inner loop over here. Now you try this and you will be telling its inner loop's domain as well. Okay,
It'll be in
look at this.
quadrant 1 and
R is equal to
4.
1 minus 2 cos theta. Let me draw this with a red color over here. थोड़ा सा confusing होएगा लेकिन चलें. Now its axis is same as at 1. Okay. Now the graph of cos always starts from the maximum or the minimum. Okay. So its first point would be this 0 minus 1. The second point would be at pi by 2, it is at 0. At pi, it will be at 3. At 3 pi by 2, it is at 0. And at 2 pi, this is again going to be at the minimum value over here, okay? So the sketch of this is going to be like this, okay? Like this. Okay, so it means that its inner loop would be somewhere between 0 to pi, and then from, if I take this as pi by 6, yeah, it is going to be 0 at pi by 6, है ना? Let me put that equal to 0. 1 minus 2 cos theta equal to 0. Oh, it is at pi by 3. Cos theta is going to be half, and theta is going to be pi by 6, or I think I should erase all of this. It is going to be let me show you this graph here quickly. It's like this, okay. You have x is at 1 again, okay, and you have here the minus 1, and here the 3. This is 90. Let me keep this in degrees. Okay, so the graph goes like this, from here to here to here to here to here. Yes, so this is going to be like this, okay. So when I want to know that what are these points here, so I need to put that was r is equal to 1 minus 2 cos theta. So I'll put this 1 minus 2 cos theta. This is basically, when I'm sketching this, I'm keeping it as y is equal to 1 minus 2 cos x, okay? So this is going to be 0. So cos x is half. So x is going to be 60 degrees or 300 degrees. Remember, cos is positive in these two quadrants, okay? So this is going to be 60 and 60. So that means if I convert this into radians, so you have here, this is going to be your pi by 3, and this is going to be your
And 5 pi by 3.
5 pi by 3 over here, okay? So if I quickly sketch this for you, bacho, So ये आपके पास यूं होएगा, we are at 0. It is at -1. I'm not going to draw that. Then we are at 60. We are again at 0. Okay. So this is going to be, then at 180, I am at 3. This is 1, 2, 3. Okay. And then
Sir, 90 पे 1 नहीं लगाना.
90 pe, yeah, we have 1. Thank you, beta. 90 pe we have 1. Thank you, beta. So, and then we have 270 pe bhi we have 1. You know, it's like this. And then 360 पे we have -1, है ना? और आपके पास इसका 60 पे ये हमारे पास आ रहा है. 0 कहाँ पे आ रहा था? 60 पे. So let me draw this 60 degrees. मैं कलर जरा चेंज कर लूँ. This looks to me that this is going to be 60 degrees. Okay. और दोबारा 300 पे है, like this. Okay, so this one is 60 पे 0 और फिर कहाँ पे 90 पे 1 हो रहा है. तो ये यहाँ से यूं आएगा ऐसे ये, और यहाँ पे ये यूं ऐसे, and here you will have your inner loop. Oh yes, this is your graph for the R is equal to 1 minus 2 cos theta. ठीक है? I think the video has gone very long.
यही वाला, ये तो हमने वही वाला ग्राफ थोड़ा ट्रांसलेट कर दिया.
Yeah, cos or sine, but you see there was small difference between them. Okay, guys, so this is it from today's session. We will be continuing these sketches, and we'll move on to cosecant, secant, tangent, and cotangent as well. Okay, thank you very much.